Enzymes are used all over, from washing powder to the food industry. So cheese is made with enzymes, bread is made with enzymes.
It's just useful in mostly all industries. You probably use it and you're just not aware.
We produce enzymes by utilising bacteria, such as E. coli, but this is along with all the other proteins they produce to survive, so we then need to purify out the enzyme we want.
So you want a really pure protein for medical uses.
Things like insulin, so people will know about that with medical needs.
And then it's useful just for research as well.
And that's really essential to get nice pure protein, to understand how they work and to understand biological processes.
Current methods of purifying enzymes are incredibly time-consuming and require a huge amount of time and effort.
I use a column, so like a cobalt column, which was really quite grueling actually. It took ages.
Standardly, people use something called a histag, which is 6 histidines, which is an amino acid, and that sticks to nickel. So you put this tag on your protein, and then you can purify it by running it down what they call a nickel column, and then the protein in question sticks to the column, everything else is washed through, and then you can elute that protein off. But then you've still got the tag attached, so then you need to cut the tag off with an enzyme, and then you purify it with dialysis a step after that. So it's quite a long and lengthy process to get to purification.
Dr. Staniland's research group at the University of Sheffield have developed MagTag, which uses magnetic nanoparticles as a quicker and simpler way of purifying enzymes.
So MagTag is something that we kind of stumbled across almost serendipitously because we were doing academic research. So I've been studying how proteins interact with magnetic nanoparticles. But what we discovered obviously is when we were finding all these particular proteins that bind very tightly, they've got very high affinity, a strong binding to magnetite. We thought, well actually this could be really useful for protein purification, because here we've got a protein that binds directly to something that's magnetic. So we could just simply magnetically pull out our protein rather than going through that very complex step of running a column, extracting, snipping off the enzyme. Using a magnet is just so easy because you can you don't have to sort of get into the solution. You can do it from a distance. So you can put a magnet on the side of a glass beaker and literally it's almost instantaneous. So it's really quick and easy to magnetically separate as a method for purifying proteins.
And having a quicker and simpler way to purify these enzymes could revolutionise the way we make them.
We need pure proteins in many industries. The purification step is a real bottleneck. So to enable us to purify proteins much faster and simpler, it is going to, I believe, revolutionise how we can purify proteins for industrial processes. As well, I think there's lots of uses that are just beyond purification. So the fact that we can bind a protein very tightly to a magnetic nanoparticle is really useful for nanomedicine. So I can see lots of avenues where MagTag could be really useful.